Hello and welcome back to another research recap. My name is Lisa. I'm your host. I'm the owner and operator of Nutrition Coaching in Life, where we help people lose body fat, gain muscle mass, improve their body composition, and their relationship with food. As some of you might know, on Wednesdays, I love to jump on here and talk about some of the latest research. Specifically, over the last few months, I have been reading from a research review called Body by Science. This is Bill Campbell's research review, a researcher whom I respect very, very much. I can only recommend you go and check out the research review. Every month they review 2 studies relevant to fat loss and muscle gain and really present them in a very, very applicable and condensed way. So I think it's great and practical for any kind of coach, whether it's fitness or nutrition coaching, and anybody who really is interested in physique enhancement or improving their own physique. So today we are going to talk about obesity drug wars. At least that's the title of the research review. So semaglutide versus Trizepitide. And this was about an original study, or taken from an original study, the review of the study Semaglutide versus Tirzepatide for weight loss in adults with overweight or obesity by Rodriguez et al. 2024. So very, very recent. Before I really dive into it, if you enjoy this kind of research recap, if you enjoy learning about the latest science in nutrition and fitness, then please do me a favor, subscribe to our channel. I also bring out 2 weekly podcasts as well as some other content. Of course, if you like it or if you have any specific requests for future research reviews, please don't hesitate to put that in the comments. I always love hearing from people and their little reviews. So in any case, let's get into the obesity drug wars. To give you a little bit of background information, or this is from Bill Campbell's research review, so I'm literally going to read from that. Longtime readers of this research review will recall that 2 previous issues were where we reviewed studies on semaglutide, sold under the brand name Ozempic for diabetes and Wegovy for fat loss. In the July 2023 issue, we reviewed a study that compared semaglutide against a placebo treatment for 104 weeks in people with overweight or obesity. The researchers assessed changes in body weight. Unfortunately, there were no body composition measurements in the study, so no muscle mass or body fat differentiation. The weight loss results were not close. The semaglutide treatment reduced body weight by 35 pounds, while the placebo treatment reduced body weight by only 7 pounds. You can see that on the left graph here. In February 2024, we also looked at what happens when you stop taking semaglutide. Do you start to gain the weight back that you lost when you were on the medication? This study also reported very conclusive results. Semaglutide caused significant weight loss when subjects were taking it, but when they stopped taking the drug, they gained the weight back. So that's the graph you can see on the right side here. Semaglutide is a type of drug that is a single action agonist. This means that the medication works through its action on one specific pathway. Tirzepatide, a newer anti-obesity medication, is a dual action agonist, which means the medication works through 2 different pathways in the body rather than just one. In the following discussion, we'll summarize how semaglutide, a single agonist GLP that only activates the glucagon-like peptide 1, works, and how Tirzepatide, a dual agonist GLP that activates both the GLP-1 receptor and another receptor simultaneously, works. So, semaglutide mechanism of action. Semaglutide belongs to a class of medications known as glucagon-like peptide 1, GLP-1 receptor agonists. This means that semaglutide is very similar to our body's natural hormone GLP-1. For GLP-1 to be effective, or for any hormone in our body to be effective, it must bind to its receptor, activating a cellular and physiological response. In this case, for the hormone GLP-1, the agonist, to be effective, it must bind to its receptor. Semaglutide is very similar to GLP-1, so much so that it will bind to the GLP-1 receptor itself and cause the same physiological response. GLP-1 and semaglutide are not identical, but they are similar. For example, GLP-1 is a polypeptide of 36 or 37 amino acids with a long chemical formula that I'm not going to try to pronounce. Semaglutide, on the other hand, is a polypeptide of 31 amino acids with a different chemical formula, but very similar. The important thing to appreciate is that the semaglutide is similar enough to GLP-1 that it can bind to the GLP-1 receptor. That is why semaglutide is regarded as a GLP-1 receptor agonist. And it can exert the same effects and, as we'll see, some enhanced effects that GLP-1 would typically have. To fully understand how semaglutide works, we need to know how glucagon-like peptide 1 works. GLP-1 is a hormone released in the gastrointestinal tract, the gut, in response to eating. One role of GLP-1 is to prompt the body to produce more insulin, which reduces blood glucose by increasing glucose uptake in the muscles. GLP-1 also decreases glucose production in the liver and inhibits glucagon secretion. Glucagon causes glycogen breakdown in the liver, which increases blood glucose levels. So very chemical, bear with me here, we're going to get into the study soon. To summarize, some effects of increased gut GLP-1 levels are limiting spikes in blood glucose levels after eating by stimulating insulin secretion and inhibiting glucagon secretion. That's not all though. Increases in GLP-1 also show gastric emptying, so the time it takes for food to empty out of the stomach. Stated differently, when GLP-1 levels are elevated, it takes longer for the food in the stomach to be transported to the small intestine, where most food is absorbed into the body. If you delay gastric emptying, you also slow down and even out the blood glucose response to a meal, which is another way GLP-1 limits blood glucose spikes during the post-mealtime period. It doesn't end there though. Another thing that GLP-1 does is it acts on the brain. The science of GLP-1 and its effects on the brain are being aggressively studied, with most of these investigations being conducted in rodent models. But still, brain GLP-1 plays a vital role in regulating appetite by creating the sensation of feeling full after a meal. Researchers from the University of Florida hypothesized that gut GLP-1 and brain GLP-1 systems do not interact. Instead, they suppress eating via independent circuits. This is a huge finding, but I need to make the point that this is a very active area of research and there is still a lot about GLP-1 that we do not know yet. Why do we need a specific medication for weight loss when all it does is mimic the effects of the hormone GLP-1? Well, remember, semaglutide is nearly identical to GLP-1, so much so that it binds to the GLP-1 receptor and causes the same downstream effects that GLP-1 would have. Why not just inject people with GLP-1 though? Well, the reason for this has to do with the half-life of GLP-1. The half-life of a drug or any substance in the body is the time it takes for a drug's active substance in your body to reduce by half. As the substance or drug's concentration is reduced in your body, so is its effectiveness. The half-life of GLP-1 is very short. Its half-life is about 2 minutes. Two specific enzymes rapidly degrade GLP-1 after it's synthesized. These two enzymes are one that's called DPP4 and one that's called NEP. I'm not going to pronounce that. Because the half-life of GLP-1 is so short, it is tough to get GLP-1 concentrations to the levels needed to induce significant weight loss. This is where semaglutide is so powerful. It has a half-life of 7 days. In essence, the hormone GLP-1 is simply incapable of reaching the supraphysiological levels needed to induce a meaningful suppression of appetite that weekly injections of semaglutide can do. The summary of glucagon-like peptide 1, GLP-1, before we even get into the study. It is secreted in the gut and the brain, and emerging research suggests that gut GLP-1 and brain GLP-1 systems do not interact. Instead, they suppress eating via independent circuits. Gut-derived GLP-1 improves glucose homeostasis via increased insulin production and decreased glucagon secretion, as well as slowing down gastric emptying. Brain-derived GLP-1 is more powerful with respect to weight loss because its appetite suppressive effects are greater. Now let's look at Trizepatide, the Tirzepatide mechanism of action. We've just described how semaglutide works by mimicking the actions of the hormone GLP-1 by binding to the receptor. This is the only receptor semaglutide binds to and is therefore considered a single-action agonist. Tirzepatide works by acting as a dual agonist. It mimics the action of glucagon-like peptide 1 by binding to its receptor, just like semaglutide does, but it also mimics the actions of another hormone called glucose-dependent insulinotropic polypeptide, GIP, by binding to its receptor. To reiterate, Tirzepatide is a dual agonist because it mimics the actions of two hormones and binds to their receptors, GLP-1 and GIP. GIP was previously in the past referred to as, as gastric inhibitory polypeptide, but we're going to refer to it as GIP. Earlier, we looked at how GLP-1 influences weight loss. It lowers blood glucose, slows gastric emptying, and acts on the brain to reduce appetite. Now, it's time to look at the role that glucose-dependent insulinotropic polypeptide, so GIP, works. GIP is a 42 amino acid peptide secreted throughout the entire length of the small and the large intestine, primarily in the duodenum and jejunum, and to a lesser extent in the ileum and colon. GIP is released naturally after a meal, primarily containing carbohydrates and fats, or if it contains primarily carbohydrates and fats, and peak GIP concentrations reach 30 to 60 minutes after eating. The prominent and recognized role of GIP is as an insulin secretagogue, so that means it helps insulin secretion to lower post-meal blood glucose levels, but more recently it has been found to have important effects on fat metabolism as well. Specifically, GIP affects fat metabolism by stimulating the enzyme lipoprotein lipase, which breaks down fat from chylomicron particles that carry ingested fats, which can then be incorporated into adipose fat tissues. So that means, again, GIP breaks down fat, which can then be incorporated into fat tissues. That doesn't sound like a good outcome though, right? Depositing fat into fat cells? Well, yeah, that's exactly what we also thought when reading about the physiological role of GIP. So if part of this hormone's function is to deposit fat into fat cells, why would we want medication to mimic the effects of the hormone in our body if our goal is to lose body weight? It doesn't really make sense. No, not quite there yet. So let's try to make sense of it. We found a great study that explains this paradoxical, hang on just a second, sorry, I'm trying to bring this up. This paradoxical anti-obesity effect of GIP. Here is the abstract of the study. Glucose-dependent insulinotropic polypeptide, GIP, is a hormone produced in the upper gut and secreted to the circulation in response to the ingestion of foods, especially fatty foods. Growing evidence supports the physiological and pharmacological relevance of GIP in obesity. In an obesity setting, inhibition of endogenous GIP or its receptor leads to decreased energy intake, increased energy expenditure, or both, eventually causing weight loss. Further, supraphysiological dosing of exogenous long-lasting GIP agonists alters energy balance and has a marked anti-obesity effect. Now it's time. This remarkable yet paradoxical anti-obesity effect is suggested to occur primarily via the brain. The brain is capable of regulating both energy intake and expenditure and plays a critical role in human obesity. In addition, the GIP receptor is widely distributed throughout the brain, including areas responsible for energy homeostasis. Recent studies have uncovered previously unappreciated roles of the GIP receptor in the brain and in the context of obesity. This article highlights how the GIP receptor expressed by the brain impacts obesity-related pathogenesis. I will obviously link the research review and the original study in the show notes, and it also contains the link to this particular paper here. So current specific evidence points to the GIP's action in the brain to reduce food intake and ultimately body weight. Obesity researchers are actively investigating the specific mechanisms of how the activation of the GIP receptor in the brain and central nervous system can reduce appetite. Unfortunately, at this time, we don't have a clear explanation of how this works. Researchers from a university in Germany chimed in on the current state of this research. Quote, however, the exact mechanisms and specific neuronal populations through which the hormone glucose-dependent insulinotropic polypeptide GIP affects energy balance and food intake remain so far largely elusive. Here's what we do know though. GLP-1 agonists induce weight loss and GIP agonists also induce weight loss. We have a drug that combines the effects of these two hormones, Tirzepatide. Just like we asked why we can't simply inject the hormone GLP-1 into the body to induce weight loss, we should ask the same question about GIP. The answer is actually the same. It has to do with how long GIP is active in the body. Just like GLP-1 has a very short half-life in the body, so that does GIP. It has a very short half-life of only 5 to 7 minutes. Once the upper digestive system secretes GIP, it is rapidly degraded after release into the circulation by the ubiquitous enzyme DPP4, and it's rapidly cleared from the body by efficient kidney filtration. The half-life of Tirzepatide is 5 days. In essence, the hormone GIP is simply incapable of reaching the supraphysiological levels needed to induce a meaningful suppression of appetite that weekly injections of Tirzepatide can do. Does this seem familiar to the relationship between GLP-1 and semaglutide? It should, because it is the same explanation. Okay, so now let's talk about the brand names of semaglutide and Tirzepatide. Before we get into the details of the study, we do want to give a brief overview of the brand names of the drugs you'll come across. We'll start with semaglutide and then discuss Tirzepatide. You'll notice many similarities with how they are taken and the conditions for which the various brand names are approved. Semaglutide is taken as a once-weekly injection in the stomach or thigh. Semaglutide is sold under two primary brands in the US, for example, Ozempic, mostly approved for type 2 diabetes, and Wegovy, approved for weight loss. Wegovy and Ozempic are essentially the same thing, semaglutide. They are the same drugs sold under different brand names from the the companies Novo Nordisk, both by Novo Nordisk. Semaglutide injection was first approved under the brand name Ozempic in 2017 as a treatment for type 2 diabetes. In 2021, semaglutide was approved under the brand name Wegovy as a weight loss medication. Tirzepatide is also taken as a once-weekly injection in the stomach, thigh, or upper arm. Tirzepatide is sold under two primary brand names in the US, Mounjaro and Zepbound. So Mounjaro is for type 2 diabetes and Zepbound for the weight loss. They are also essentially the same thing, Tirzepatide. They're the same drug sold under different names from, where are we? A company called Eli Lilly. Tirzepatide injection was first approved by the U.S. Food and Drug Administration under the brand name Mounjaro in 2022 as a treatment for type 2 diabetes, and in 2023, the FDA approved the drug under the brand name Zepbound as a weight loss medication. So finally, let's get onto the study. Who was in this study? Subjects were first-time users of Trizepitide or Semaglutide with overweight or obesity, and so no previous history of taking these types of weight loss medications. About half of the subjects had a type 2 diabetes diagnosis. The following table, as you can see, summarizes the subjects' demographics. So on average, 52 years of age, 70% female and 30% male. On average, 242 pounds, BMI of 39, and about half with type 2 diabetes. Now, what did the researchers do? This was not a typical randomized intervention study where researchers recruited subjects and then randomized them to take either semaglutide or Tirzepatide. Instead, this was a retrospective observational cohort study. So the researchers were able to look into the health records of patients who were dispensed either semaglutide or Tirzepatide and see how effective each medication was for weight loss outcomes. The subjects' records were taken from a subset of Truveta data. Truveta provides access to continuously updated and linked electronic health records from a collection of U.S. healthcare systems. The researchers identified the subjects that were dispensed Tirzepatide and semaglutide between May 2022 and September 2023. The initiation date of the study was important as May 2022 was the first month that Tirzepatide obtained approval. Initially, over 40,000 subjects met the inclusion criteria for the study, meaning that the researchers identified over 4,000 patients' records in which the subjects were dispensed one of these two medications and had a medical diagnosis code indicating a BMI of greater than 27 or greater than 30. Since semaglutide had already been on the market for several years and Tirzepatide was just approved, most of the patients' records identified semaglutide as the medication being dispensed, with much fewer dispensed Tirzepatide. Specifically, 78% of the medications dispensed were for semaglutide, with only 22% for Tirzepatide. A common strategy researchers employ in retrospective observational cohort studies like this one is propensity score matching. The propensity score allows one to design and analyze an observational or non-randomized study to mimic some of the characteristics of a randomized controlled trial. Stated more simply, this technique makes a less robust observational study, such as this one, more like a gold standard randomized controlled study. Essentially, what the researchers did was keep all the Tirzepatide patients in their database and then match them with patients dispensed semaglutide who were as close to the Tirzepatide patients with respect to age, weight, ethnicity, education, type 2 diabetes classification, comorbidities, and medication use. After the propensity score matching, there were still 9,139 subjects in the Tirzepatide group and 9,192 subjects in the semaglutide group. The subjects in the study were followed until one of these occurrences. End of the study timeline, so November 2023, medication discontinued, more than 30 days without medication at hand, switching to a different weight loss medication, or no more patient records in the database. What about the dosing of semaglutide and Tirzepatide? The dosing decision was based on the treatment of type 2 diabetes, not weight loss. This may sound confusing since the study's primary goal was weight loss. The researchers included records of patients being prescribed and dispensed medication for type 2 diabetes, but the primary research question was the amount of weight loss that occurred during the treatment. Dosing of weight loss medications. Here are two direct statements from the research article that help explain the purpose of the study and the dosages of the two weight loss drugs used. Accordingly, we aimed to compare on-treatment weight change between Tirzepatide and Semaglutide injection labeled for type 2 diabetes in a large clinical population. We relied on brand as a proxy for target dose. The standard full dose is 0.5 milligrams for semaglutide, labeled semaglutide, and 5 milligrams for Tirzepatide. The standard dose escalation schedule for both drugs is 4 weeks. What physique-related outcome variables were measured? Let me get into this. Weight loss as a percentage in body weight was the primary variable of interest. For example, if a subject weighed 100 kilograms, so 220 pounds, at the start of the study and lost 10 kgs, so 22 pounds during the study, they obviously lost 10% of their body weight. The most recent body weight within the 60 days before taking the weight loss medication was considered the baseline body weight value. Follow-up body weights were obtained from the subject's health records included in the analysis. In addition to weight loss, the researchers also assessed gastrointestinal side effects. The side effects the researchers monitored were bowel obstruction, cholecystitis, I can't say this word, a few other gastrointestinal issues. If subjects had a history of these conditions prior to the start of the study, their data was actually excluded from the analysis for that specific condition. This makes sense because in these cases, the condition should not be attributed to the weight loss medication when the subjects had the condition before the medication use. Makes sense. So what were the results? Both groups of subjects lost a significant amount of body weight as the study duration progressed. Treatment with Tirzepatide caused significantly more weight loss at all time points, so 3 months, 6 months, 12 months of medication use compared to just semaglutide. We can see that here in this graph on the left with the yellow being Tirzepatide, or orange, sorry. When we look at the number of subjects who lost 5%, 10%, and 15% of their body weight after 1 year of treatment, we see a similar outcome. Tirzepatide was superior to semaglutide. Specifically, for each weight loss threshold, the researchers reported the following data. So you can, again, compare Tirzepatide and semaglutide in terms of percentages in this graph. So now we have Bill's interpretation of the data. Tirzepatide clearly seems superior to semaglutide for weight loss. The researchers had a similar conclusion. In the discussion section of the published paper, they made this statement. In this large clinical analysis of U.S. adults with overweight or obesity who initiated Tirzepatide or semaglutide treatment, those receiving Tirzepatide were more likely to achieve 5% or greater, 10% or greater, and 15% or greater weight loss and experienced larger reductions in body weight at 3, 6, and 12 months point. Now, still, let's look at the gastrointestinal effects. Tirzepatide was better for weight loss than semaglutide. However, did this weight loss advantage come with greater side effects? That's the question. The answer is no. There were no significant differences in gastrointestinal side effects between the Tirzepatide and semaglutide users. The authors of the study made this statement. We observed no significant differences in the risk of any gastrointestinal adverse events between those receiving Tirzepatide versus semaglutide. The researchers reported the gastrointestinal side effects data by listing each side effect and its occurrence per 1,000 person years. Not entirely sure how that works. Oh, here. Per 1,000 person years is a unit used in research, particularly in epidemiologic research, which is what the study was classified as, to express the rate of a side effect occurring within a population over a specific period of time. Person years, quote unquote, represents the total time All subjects in a study contributed to the research, essentially combining the number of people with the duration of their participation. Stated differently, per 1,000 person years means the rate of the event happening for every 1,000 years of combined study time across all participants. Sounds very complicated. This unit is valuable when analyzing data from studies where participants may drop out at different times, as it accounts for the varying lengths of follow-up for each subject in the study. Here's an example of using this unit. Let's say a study followed 1,000 people for 2 years. There would be a total of 2,000 person years of data. If 10 case studies of a side effect were observed in that study, the incident rate would be calculated as 5 cases per 1,000 person years. Okay, that actually makes sense. Oh, sorry, I skipped that slide here. We would like to see low numbers as we look at the gastrointestinal side effect data reported from the study. A low value per 1,000 person years means very low side effects were observed in the study. This table summarizes the adverse effects. Okay, I mean, it's not low, I would personally say. I mean, for some of these conditions, like as much as 20 1,000 person years, so that's nearly 2 out of 100, I guess, if I'm reading this correctly. But anyway, moving on, let's talk about the strengths and limitations of this study. So one of the strengths was certainly the timing of the study. We love the speed with which this study was initiated. The study was initiated at the same time, or month actually, as the newest anti-obesity medication, Tirzepatide, was approved. In many instances, science moves somewhat slowly, but not in this case. Another strength was the number of subjects. Over 18,000 subjects overall observed in the study. While this is not uncommon for observational studies, the propensity score matching of the subjects in the 2 treatment groups made this more like a randomized controlled trial, or study anyway. Now, some of the limitations. So it was not a randomized controlled trial. The gold standard research studies are randomized double-blind controlled clinical trials. This study was an observational study, which is more likely to be influenced by data analysis bias, although we did not detect any problems with how the data was analyzed and presented in this study. Now, the use of clinical electronic health record data could also be a limitation. So as a retrospective observational cohort study, the data collected was from electronic health records. While this type of data collection is very practical and within a real-life setting, it has some obvious limitations. First, body weight. Excuse me. Just giving me a little bit of issue here in my notes. First, body weight. Assessment were not standardized throughout the study intervention, but could only be obtained when the subjects had their medical appointments. Another limitation that the study's authors highlighted was that adverse events are likely underreported compared to prospective controlled randomized clinical trials. And then the last limitation they reported was that there was no body composition data, so the only data available from the electronic health records was body weight. There was no assessment of body fat losses or changes in muscle mass. When a study has no exercise intervention like this, we can be confident that approximately 75% of the weight loss comes from body fat and about 25% from muscle mass stored, or lean body, lean tissue. Okay, well, I hope you enjoyed learning about GLP-1 and GIP-1. I have to say, for me, GIP was certainly new. I was not even aware of that. I live outside of the US, so I didn't even hear or hadn't even heard of Trizepatide, but clearly a little bit behind the moon on that front. So I'm glad that this issue of body by science was able to catch me up a little bit. I would love to hear your thoughts and experiences and advice for people considering a GLP-1 agonist medication for weight loss. I personally think it very much depends on the reason they want to jump on it, what they've tried in the past, how obese or overweight they are. If someone's looking for a quick fix, if someone is just trying to get out of lifestyle and habit changes, I personally am not an advocate. What I have heard so many times though is that they really do help blunt that food noise that we often hear from clients when they're just saying like, I can't stop thinking about food. Like all I think about is food. And so they clearly help with that. But I think they always have to be under good medical supervision so that the dosing is right. And when people come off it as well, that we're slowly sort of tapering off. And on top of that, that we are exercising at the same time, that we are focusing on improving food quality. And with that, bringing up protein intake so that we are mitigating any kind of muscle loss during the time, and that of course afterwards we're setting ourselves up for success by already having good habits in place when it comes to our exercise and also the food that we're consuming. So yeah, I hope you enjoyed that. Once again, if you did, please do me a favor, subscribe, leave me a comment, and I will speak to you the next time.